Welcome to the Pod-Key Summary of Machine Learning and AI Group Lab from WWDC 2026. A lot of Apple AI development right now comes down to one practical question: what belongs on the device and what belongs in the cloud? The big themes here are trade-offs, measurement, and graceful fallback. Faster isn't always simpler. Cloud isn't always slower. And the teams that do this well are the ones actually testing their assumptions instead of guessing. The headline difference is pretty clear. On-device models give you offline support and a much smaller context window, around 4 KB, while private cloud models stretch to 32 KB and add a reasoning level that lets the model think a bit before it answers. So if your app needs to keep working on a plane, in a tunnel, or anywhere connectivity gets flaky, on-device has obvious appeal. If the task is more complex, needs more context, or benefits from that extra reasoning step, the private cloud option opens up a lot more room. And the recommendation here is refreshingly unglamorous. Don't pick based on vibes. Run comparative evaluations and see which one actually fits your latency, connectivity, and feature needs. Apple's evaluation framework is really the center of this whole workflow. You can instantiate the same service class against either the on-device model or the cloud model, run the same test suite, and generate side-by-side reports in Xcode. That means you're not comparing two totally different implementations. You're comparing deployment choices with the rest of the app held steady, which is exactly what you want if you're trying to make a sane engineering decision. There's also a dynamic profiles API for hybrid setups. Simple requests can stay local. More complex ones can get handed off to the server model, and you still preserve shared context across that handoff. That's probably where a lot of real products land, because most apps don't live at one extreme all the time. There's a nice reality check in the performance guidance too. On-device inference cuts out network latency completely, but that doesn't automatically make it feel faster. If token per second throughput is slow, the user still feels that drag. Local can be private and available, and still feel pokey. Meanwhile, with a good connection, round-trip latency to a cloud model can be small enough that it barely matters in practice. Foundation One's instruments now expose things like latency and token budgets, so developers can measure actual snappiness instead of arguing about it in the abstract. That also gives you a way to tune prompts or model choices based on what the user experiences, which is usually the metric people remember anyway. Versioning is also a little different depending on where the model runs. On-device models are tied to OS releases, so the main way to detect a model change at runtime is simply checking the OS version. Server models are trickier because they can change silently. So, instead of hard-coding version assumptions, the advice is to rerun evaluations after OS updates or server updates and catch regressions that way. It is less glamorous than a neat version check, but also a lot closer to reality. On iOS, on-device models can run in widgets, app intents, and background tasks, which is useful if you're building features that need to be available outside the main app. But iOS may rate limit that work when system resources are tight, and it can return specific errors so the app can retry gracefully instead of just face-planting. macOS is looser here. It doesn't impose the same rate limits, so continuous background inference is more viable. On iOS, quality of service priorities still matter, and the system will favor foreground work, which, honestly, is probably what most users would want when their battery is on the line. For teams training or adapting their own models, the path here looks pretty open. You can fine-tune open-source models from Hugging Face, bring them in through Core AI or MLX, and then evaluate incremental gains using the hill-climbing approach described in the evaluation framework. Adapter-based fine-tuning also gets a nod, including small per-user adapters that can be quantized to stay inside on-device memory limits while still preserving personalized behavior. That memory limit matters a lot. A practical rule of thumb is to keep on-device model assets under about 2 GB on iOS, so you don't push system memory too hard and trigger throttling. Quantization, like moving to 8-bit, can shrink much larger models, potentially even 6 billion parameter language models, into a range that's usable on device. But again, the theme repeats. Don't assume the compressed version is good enough. Validate the accuracy loss through evaluations. If you've already got Core ML infrastructure, the migration story to Core AI sounds fairly manageable. A thin wrapper can abstract the API differences, so apps can fall back to Core ML on older OS versions and use Core AI on iOS 27, and later without a huge rewrite. And for people working in PyTorch-heavy workflows, MLX looks especially useful. It supports more than 10,000 Hugging Face models out of the box, which makes macOS a nice place to experiment before deploying the same weights to Core AI on iOS. That's a pretty practical bridge between research mode and shipping mode, which are often farther apart than anyone wants to admit. One of the more sensible product notes here is about what happens when foundation models just aren't available. Maybe the device is older. Maybe Apple Intelligence is turned off. Maybe the feature simply isn't supported in that context. The recommendation is not to throw an abrupt error dialog at the user. Either hide the AI-driven UI entirely, or guide the user toward enabling the feature. It's a small thing, but it makes the whole product feel more intentional. Nobody enjoys tapping a button that basically says, "Surprise, this doesn't work here." The overall message is pretty grounded. Choose local, cloud, or hybrid based on measured behavior, not ideology. And keep reevaluating as models and platforms change. A lot of this comes back to respecting constraints, from context windows to memory limits, to whether the user is offline in a parking garage somewhere. And honestly, if your AI strategy survives both Xcode reports and a bad cellular connection, you're probably on the right track. This episode was generated by Podkey. Create your own at podkey.fm.